Hello learners, previously Form 4, Topic 2, Lesson 13, we were dealing with calculating Hess's law using the Philip formula. So today, Lesson 14, we are going to do the relationship between heat of a solution, lattice energy, and hydration energy. So heat of a solution is given by the formula lattice energy plus hydration energy. So what is lattice energy? Lattice energy is the energy change when 1 mole of an ionic compound is formed from its constituent ions in the gaseous state. For example, we're having a sodium ion in a gaseous state plus chloride ion in the gaseous state, forming an ionic compound which is sodium chloride, which is solid. So this is lattice energy. So the enthalpy change here is negative. So we are told if the equation is reversed so that the bond is broken in the ionic compound to form gaseous ions, that's sodium ions and also chloride ions, lattice energy becomes positive. We have even seen this in Hess's law. If you reverse this equation, that means the sign of the enthalpy change will also become opposite, or it will be positive if it was initially negative. Okay, that is lattice energy. What's lattice energy? The enthalpy change or the energy change when 1 mole of an ionic compound is formed from its constituent ions in the gaseous state. Hydration energy. What's hydration energy? Hydration energy is the energy change that occurs when 1 mole of gaseous ions become hydrated. So we're saying hydration process involves formation of new bonds between polar water molecules and the ions. Hence, it is an exothermic process. So factors affecting the hydration energy include the size of the ion and the charge on the ion. So we are told note, the smaller the ionic radius, that's based on the size of the ion, or the greater the charge on the ion, that's the charge on the ion, comma, the greater the hydration energy. And the opposite also does. That means the bigger the ionic radius, or the lesser or the smaller the charge on the ion, now the lower the hydration energy. That one can be also happen. Okay, formula for heat of solution, we have said earlier on, we said is equal to lattice energy plus hydration energy. So the formula will be enthalpy change of solution or heat of solution will be equal to lattice energy plus hydration energy. Okay, thereafter, we go to the next thing. We are having energy level diagrams for the overall enthalpy change of solution can be exothermic reaction. So the heat of a solution can be exothermic if the hydration energy is greater than the lattice energy. So, for example, you are calculating the heat of a solution and you have realized that you have gotten a negative enthalpy change. That means the hydration energy was greater than the lattice energy. That's why you have gotten a negative enthalpy change, and that's why that reaction, that's the heat of solution, became an exothermic reaction. So the energy level diagram, because during the exam you can be told draw the energy level diagram for the above change. This is how it will look like. So we're having energy in kilojoules per mole, and here we have the reaction pathway or reaction progress, or we can put even reaction path or reaction coordinate. So here we are having the solid. So this is the ionic compound. For example, if you are dealing with that side of magnesium chloride, so this is the ionic compound, it is solid. So up here we have the lattice energy, and lattice energy is positive here. It is positive. What is lattice energy? It is the enthalpy change when 1 mole of an ionic compound is formed from its constituent ions. But we said if we start with the ionic compound and they are going to form the ions, that means we have reversed the reaction. So if we reversed, that means we also reverse the sign. Because initially it was negative, now it became positive because the ionic compound now is broken. And bond breaking is endothermic, so it's going to have a positive enthalpy change. Or lattice energy will be positive. So here we are going to have now the ions of this ionic compound. So in our case, if we have a magnesium chloride, which is our ionic compound, we are going to have Mg2 plus. That N plus, N is the valency for that metal or that cation. Then the other side here, we are having chlorine. So we are having 2 of chloride ions. So here we are having negative alone, 1 which is hidden. So we are going to have 2 Cl. What I mean is we are going to have Mg2 plus gaseous state plus 2 of chloride ion, again gaseous state. That's what we are supposed to have. So this other side, we are going to have hydration energy, and hydration energy is negative. So this is an exothermic reaction. We said hydration energy is greater. That's why you can see the hydration energy is greater than the lattice energy. So here we are going to have Xn plus aqueous. That means your X was magnesium. So here you are having magnesium ion aqueous, then plus we are having 2 of chloride ions, which is aqueous. So this is hydration energy, because we said hydration energy is the enthalpy change that occurs when 1 mole of gaseous ion becomes hydrated. So in our case, we are having magnesium ion, which is in the gaseous form, and it became hydrated. That means it became aqueous state, like that. So here we are having the enthalpy of solution, the one that we are calculating. Now, how do you get now enthalpy of solution? Enthalpy of solution will be gotten by lattice energy plus hydration energy. So in our case, lattice energy is positive, but hydration energy is negative. And if you check now, lattice energy is smaller. So that means hydration energy, which was having negative, is now greater. That means leading to a negative enthalpy of solution. Okay, so don't forget how to draw this energy level diagram for an exothermic reaction or a negative enthalpy of solution. When you get the negative enthalpy of solution, this is the expected energy level diagram that you are supposed to draw. So you have to know overhead how to draw this. So by 2, we are going to go to for exothermic reaction. For example, you are calculating the heat of solution and you have gotten a positive heat of solution. That means that's an endothermic reaction. And the reason is that lattice energy was greater than the hydration energy. So that one will result to have a positive enthalpy of solution. So we have again the same energy in kilojoules per mole. Here we have reaction pathway or reaction path or reaction progress, or you can say reaction coordinates. So here we have the ionic compound XY, which is solid. So this is the lattice energy. Remember, in endothermic reaction, the lattice energy is greater. You can feel the distance there compared to the hydration energy, which is now smaller in our case. So lattice energy is positive because here we're having the ionic compound being broken down now to form gaseous ions. And we said bond breaking is endothermic reaction. That means we are going to have a positive enthalpy on the side of lattice energy. So for example, if you are dealing with maybe that side of sodium chloride, you're having sodium chloride which is solid. So the lattice energy here, we are going to have sodium ion, which is gaseous, and also chloride ion, which is gaseous ion. So when these gaseous ions become hydrated, we are going to get sodium ion, which is aqueous, plus chloride ion, which is aqueous. So here we are going to get heat of solution here, and this heat of solution will be positive because lattice energy here is positive. So this hydration energy is negative. When we add, we said enthalpy of solution is equal to lattice energy plus hydration energy. We are going to get a positive enthalpy of solution. That's why we are going to have a positive enthalpy in the side of heat of solution. Okay, learners, you have to know these two energy level diagram for endothermic reaction and for exothermic reaction. That's the end of our video.